All right, now we're going to be sketching radical functions. So we're going to do the same as we did in the last ones. We're going to analyze the function f of x is equal to negative x times the square root of 4 minus x squared. And then we're going to find each of these pieces and then make a sketch out of that, right? So, all right, let's start off with the domain. So the domain is going to be take a little bit more work to figure out than the last ones. So let's look at underneath the square root here, right? We know that that has to be greater than 0, right? That can't be a negative. So let's say 4 minus x squared, and I'm just going to make it equal to 0 for a second just to figure out what my points of interest are. Okay, so if you rearrange this, you end up getting x is equal to plus or minus 2. Okay, just taking the square root, stuff you guys have done for a while. Okay, so those are my points of interest. So I am going to make a little straighter. Number line there where we've got negative 2 and 2, right? And then we're just going to look at these different intervals to see where it's positive and where it's negative, right? So let's throw in negative 3, right? So if we threw in negative 3 into this, okay, then that would be like 4 minus, and then negative 3 squared is positive 9, so 4 minus 9, right? I'm going to be into negative territory. So this is negative over here. Okay? And in the middle, if I threw in the point, let's say 0, right, anywhere in the middle there, I'm going to end up positive. And then on the other side, if I threw in, let's say, positive 3, then that's 9 again, so that'd be 4 minus 9, so into negatives. So it looks like this is my interval, right? That's where I'm going to be okay. It's going to be between negative 2 and 2. Okay, so the domain here, so domain, if we're doing this in interval notation, would just be from negative 2 to 2. All right, so for my intercepts, if I do my x-intercept first. So for my x-intercept, my y has to be 0, so it'd be 0 is equal to negative x times the square root of 4 minus x squared. Okay, so for this guy, it's kind of like we're already in factored form here, like where I can ask myself, what would x need to be to make this equal to 0? So in this case, right, because of that one, x would be equal to 0, right? That'd be one of them. And then even though this is under the square root, I can still look on the inside, right? Because it doesn't really matter if I take the square root of these things that are going to be 0 too, right? Where in this case, it would be x is equal to plus or minus 2, right? Like if you set 4 minus x squared equal to 0 and solve for x, you get these, right? So those are my 3, right? Those are my 3 x-intercepts there. All right, y-intercept. So our y-intercept is going to be when x is 0. So if I throw in, so y is equal to negative 0 times the square root of 4 minus 0 squared. Doesn't really matter. It's times 0, so it's going to be 0, right? So, okay, that kind of tells us that it goes through the origin as well, right? All right, so symmetry. So symmetry, we are going to throw in f of negative x and see what we get out, right? So f of negative x is equal to, so let's see the original here. So then it'd be negative, and then instead of an x, I'm going to put in negative x times the square root of 4 minus, and then negative x squared. So that is equal to just x times the square root of 4. Now I know this looks like plus. I almost made that mistake too, but it's negative x squared, right? So that's going to become positive, and then we're just minus that, right? So minus x squared. Okay, so then in this case, this is look at the original, right? The original function was so f of x was equal to negative x times the square root of 4 minus x squared, right? Do you see that in this case, this would be the same thing as going like negative times negative, so positive square root of 4 minus x squared, right? So negative f of x, right? That's the same thing we got going on here, right? Because that would simplify to the same thing here. So we have f of negative x is equal to negative f of x. So this thing has odd symmetry. Okay, looking at asymptotes. So asymptotes on a radical function, no, does not exist. Okay, areas of increase and decrease. All right, so now we got to take the derivative, and I can't do the same little trick I did in the last one. We have to do the product rule. So we've got negative. Let's write it again. So we've got f of x is equal to negative x times the square root of 4 minus x squared. So I'm going to call this my f and that my g, right? And we're going to have to do the product rule here. So f prime of x is going to be negative x times then the derivative of g, which will be 1/2 times 4 minus x squared to the negative 1/2 times negative 2x. Okay, all of that plus, and then derivative of f, so that'd be negative 1 times, and then g, so square root of 4 minus x squared. And actually, you know what? Called that square root. Why don't we call that to the power of 1/2 for now? Just so it looks similar to what we already have, right? So now what I'm going to do, I'm going to factor out what I can out of this, right? Well, actually, you know what? Let's clean this guy up a bit first. Let's do one more row here. So we've got negative x on the front there. I see I've got like another x over here, so those are going to become x squared in the end, right? I also see I've got a negative 2 and then a 2 on the bottom. Those will cancel. But I got to keep track of my signs here, right? Because I got a negative and a negative. So that'll become positive now. So I've got positive x squared. And that's kind of it, because the 2's cancel and the negatives cancel. So that's it for those. And then times 4 minus x squared to the power of negative 1/2. And then this part, so this is plus negative 1. So I'm just going to call that minus 4 minus x squared to the 1/2. Now there's two approaches to this, actually. You could rewrite these in radicals, right? I could write this as in the denominator, and then find a common denominator for both, right? But so I'd have to find a common denominator. Or the other one that's kind of handy if you're getting good at it, we could factor out this, right? We could factor out 4 minus x squared to the negative 1/2. And then that works as well. So either one of those method works. I'm going to do this one where I factor this one out with the negative 1/2, because it's going to make this one look nice. All right, so let's do that. So the next row here, what I'm going to do is I'm going to factor just that. So I've got 4 minus x squared to the negative 1/2. Okay. And then what I'm left with would be x squared. And then this is gone, right? Minus. And now this is kind of the thing to get your brain wrapped around. We've got a 1/2, and then we divided out this one, right? So remember, when we divide, we're really adding. Or sorry, we're really subtracting. But when I'm going to go minus negative 1/2, so that's going to be adding in the end, right? So that's going to be 1/2 plus 1/2. This is going to become just 4 minus x squared to the 1, if you like, but just that, right? There you go. So let's clean this guy up. So this will be 4 minus x squared to the negative 1/2. And then this one would be, I'd have to distribute that negative in, right? So this will become 2x squared minus 4. And then I'm going to write this out just with radicals again now too. So this would be equal to, so this was to the negative half, so that's in the denominator. So this is in the numerator. And I'm going to factor out a 2 as well. So I'm going to say 2 and then x squared minus 2 over the square root of 4 minus x squared. Now remember, we were setting this equal to 0, right? Or figuring out our critical numbers. So I'm going to look at the numerator for where it's equal to 0. So that would be at, well, that would be at x is equal to plus or minus the square root of 2. Right? If I just set this equal to 0, right? And then in the denominator, right, my non-permissible values, this is going to be where x is equal to, and then again, this would be, well, I guess not again, it'll just be plus or minus, and then actually just 2 when you solve for that one, right? All right, so let's make our number line. Okay, so we are going to have a number line at, so negative 2. And then the square root of negative 2 would be the next one. But just for the sake of simplicity here, why don't we just call that negative 1.4 for a second, just so we can easily figure out some test points. Okay, and then we're going to have 1.4. And then we're going to have 2. All right, so now, yeah, so you would want to figure out negative 3, right? You know, some kind of test point over here. But, if you go back to the beginning, wasn't this our domain? Right? Negative 2 to 2. Like, our graph doesn't exist over here or over here, right? The original function. So, yeah, that's going to be the case on this one. So f, so you can say f prime of x, even though you could put numbers in, right? Well, you know, like you could try to put numbers in, but what you're going to end up doing, if I put negative 3 into this one, right? It does not exist. Yeah? So that's not going to work at all in that case, right? So then, you know, f of x does not exist either. But we already knew that, didn't we? All right, so now if we look in this interval, it's a little bit annoying when they're decimals, right? But same idea. So let's put in a number like, you know, negative 1.9, right? Into this. So if I put like negative 1.9 into this, negative 1.9 squared is above 2. So this is going to be positive on the top. Right, this will be positive there. And then this will also be positive on the bottom because negative 1.9 squared isn't over 4, right? So 4 minus a number less than 4 is going to be positive, right? So in this interval, it's going to be positive. Okay, so that means this thing is going to be increasing for f of x. And then between negative 1.4 and 1.4, so I could throw 0 into that. Yeah, so in that case, this is going to be, we'll throw 0 into that as negative on the top. And then 0 into the bottom, that's going to be positive on the bottom. So this will be negative. So this is going to be decreasing. And then really for the same reason as this one, this will also be positive, right? If you put like 1.9 or something like that in there, into the top and bottom, you'll get positive and positive again. So this will be positive. So this will be increasing. And then on this side, we know this from this one too, right? We can't have any number bigger than 2, so this does not exist. So then the original function does not exist either. All right, so this thing is going to be increasing on the interval from negative 2 to, and then remember, we should be right with this. This is negative root 2. Okay, and then unioned with root 2. And then 2, right? That was negative root 2, and that was root 2. Oh, not that one, root 2. Okay. Okay, so then this thing is decreasing on the interval from negative root 2 to root 2. All right, so it seems pretty obvious where our maximum must be, right? It's got to be at negative root 2. So let's do our max. Is going to be at f prime of negative root 2. It's not f prime, just f of negative root 2, which is equal to, and then if you threw that in, that'd be negative, and then negative root 2, just throwing it into the original function, times the square root of 4 minus, and then negative root 2 squared. Okay, so this ends up being, well, this would just be root 2 for the first one here. And then this one, right, just be careful on this, because this would be, well, that negative is going to become positive because I'm squaring it. And then the square root of 2 squared is just 2. Okay, so this becomes, here, I'll just do one more step, 4 minus 2, right? Hopefully that made sense, which is just root 2 times root 2, which is equal to 2. That worked out nice. Okay, so your max point there then would have been the point negative root 2 comma 2. All right, so your min, I'm going to get a little lazier. It'd be a very similar situation to the last one, but it ends up equaling negative 2. So then your point would be at root 2 comma 2. Okay, concavity. All right, so for this one, let's write out, if I got enough room here, let's write out f prime of x again, because that's going to, and that was, and I'll expand this part too, so it was 4x squared minus 4, and then times 4 minus x squared to the negative a half, right? So just rewriting this really, right? But I had the 2 expanded in as well still. Okay. All right, so there's my f and there's my g, and I'm going to do product rule. So let's get to work on this. So this will be just f, so that would be 2x squared minus 4 times, and then this would be negative a half times 4 minus x squared, okay, to the power of negative 3 over 2, and then times the derivative of the inside, so then that would be negative 2x, and I add one more bracket to close that, plus, and then the derivative of f, so that'd be 4x times 4 minus x squared to the power of negative a half, which was just g. Yeah. Okay, so there it is. There's the derivative. Now we just got to go to work cleaning this thing up, right? So this would be, so looking through here, well, I got that x there. I'm going to put that out front, right? And, well, in this case, I've got this coefficient, negative 2, and then I look over here too, and I got negative a half. You guys kind of see that the two of those together would end up just giving you positive 1, right? So out front, I'm going to have, well, positive 1 x, right, just that x, and then I'm going to write the other 2. So then I would still have 2x squared minus 4, and then this part as well. So then it was 4 minus x squared to the power of negative 3 over 2. Okay, so that was all of that. And then left on this side would just look the same. So then that would just be plus 4x times 4 minus x squared to the negative half. All right, now I'm gonna do my little technique of factoring out. I think it's gonna be the one to do. So let's look what we got to factor out. We've got x, right? They're common to both. And then the 2x minus 4 isn't, but I've got an x minus x squared, right? So this one and this one. And here's the trick. I'm going to factor out the one with the lowest exponent here, and then magic's going to happen. So let's see what happens. So I'm going to factor out an x, and then I'm going to take out a 4 minus x squared to the power of negative 3 over 2. Okay, and then I'm going to write what I have left. So now that I've done that, I've still got this guy in that first term. So we've got 2x squared minus 4. And then on to the next term, I've still got this 4, so it's plus 4. And then this is where the magic happens. What happens to this? Okay, well, we've got, let's actually just write it down. So remember what we do with our exponents when you factor them out, right? We've got negative a half minus negative 3 over 2. So this becomes 1/2 plus 3 over 2, right? That's really what's going on there. So that's 4 over 2, right? So that's going to be 2. Shoot. You guys might have saw my mistake there. My bad. That's like negative a half. I knew that wasn't working out as well as I thought. That's like negative a half minus negative 3 over 2. So that was where the mistake was. So then that's like negative a half plus 3 over 2. Okay, so that's 2 over 2, which is even better because that's 1. There, that's better. So now that's what my exponent is, right? So that's going to be 4 times, and then it would just be 4 minus x squared to the power of 1. Okay, so now let's go to work cleaning that up. So that would be x times 4 minus x squared to the power of negative 3 over 2. And then for this part now, this would just be, well, I'll distribute that one out. So we get 2x squared minus 4 plus 16 minus x squared. And then we'll just collect those like terms. Okay, so then that was just x squared, right? That one and that one collect. And then plus 12. All right, so let's just rewrite this a little different just to make it look a little nicer. So in the end, we've got x times x squared plus 12 over, and then it would be the square root of 4 minus x squared to the power of 3. Or leave that as a fractional exponent too. That's fine. Either one of those would be fine. Okay, so that's it. So there's our second derivative, right? So let's now, hopefully you guys have more room than me. Sorry if you don't. We'll set up our number line here, but we'll have to figure out where, I'm kind of getting ahead of myself, where our critical numbers are for this guy, right? So on the top, we want to know where it's equal to 0. So that's going to be x is equal to, and it'll be 0 from that guy. So x is equal to 0. It'll also be x is equal to, and then from this one, it would be the square root of 12, but it'd be plus or minus the square root of 12. Which would also be the same thing as plus or minus, if we took out as much as we could there, that it'd be 2 root 3.